All right, be prepared to be a little challenged. This says use the basic identities, which means all of these, to simplify. So that's all you're doing, the expression. Well, I look at this and I look at this and I say, what should I do? One thing I did not say in the pre-lesson, 99.999% of the time, do not mess with sine or cosine. Why, Mr. Cleefish? It's just a hidden little rule that you just need to put all your trust in, okay? So, with that being said, what did I just say about this? I said don't mess with it, which is implying mess with this. What do you mean mess with it? Well, look for it. Where is cotangent on this whole page? Well, here it is, but I definitely don't want to substitute that. That's just making life miserable. Here it is. Here's another cotangent all by itself. It equals cosine over sine. So I'm going to substitute that. Watch this, you guys. Cosine, I'm going to use x because they used x initially, over sine times sine. Now look, these cancel. What are you left with? Cosine. Remember, these problems were made by math nerds. They want you to feel the adrenaline rush of having things simplify because that's the whole point. So, here we go. Look at this guy. This guy's jumping out at me. By the way, I am a math nerd, so that wasn't hate. That was love. Nothing but love. Cosine of pi over 2 minus x. See, that could be theta. It's the same thing. Where is that? Where is that exact same thing? It is right here. What does that mess look like? Well, it equals sine. So I'm going to take it out, and I'm going to replace it with sine. Now I'm going to go with x times, now what is cosecant? Got to go on the hunt for it. There it is. It's 1 over sine. And I'm just going to use x. And look at it. That's like this. So these would cancel, and I would just swoosh, and I'd get 1. That crazy looking thing reduced to 1. Is this weird? Well, it should be. This is new. It's going to take some getting used to. Some are harder than others. All right, cotangent squared plus 1. Well, where's all our squared stuff? That's up here. What does this say, though? Cotangent squared plus 1? Well, it's right here. You just got to get good at hunting for it. So I'm going to take that out, and I'm going to replace it with cosecant squared. Uh-oh, I went to theta, so I'm going to have to change the bottom one to theta just to stay consistent. Sorry about that. Am I done? And that's another frustrating thing. You feel like you've done something, so you should have earned the right to be done. But the thing is, this could easily continue moving forward. Now, remember what I said. If cosecant is right here, and it equals 1 over sine, then cosecant squared equals 1 over sine squared. And so what I'm going to do is I'm going to take a shot at it and see if this cleans itself up. And again, this only comes with experience, that I would know to try something else. Again, these are made by mathematicians who want the end to be super simple, so you feel like you can really pat yourself on the back. Secant squared. Well, here's secant, but if I insert a squared there, then I have to insert a squared there. So I'd get 1 over cosine squared theta. Now wait a minute. If I have a fraction in the numerator divided by a fraction in the denominator, I can think of it as this divided by this. So I take this guy and I flip it. Basic Math 101, flip and multiply. So I get 1 over sine squared theta times cosine squared theta over 1. And then I can't cross reduce, so I swoosh. And then I think to myself, can this go any further? Sorry about that, guys. I got off the page there. So I flipped this and multiplied it, and I showed my work here. Nothing cross-reduced, so I swooshed. Now I go on the hunt. Where is their cosine over sine? Isn't it right here? So if I inserted a squared here and a squared there, I could insert a squared there, and that stuff equals that stuff. So this whole crazy thing reduced to cotangent squared theta. Now on the scale of 0 to 10 for you guys, that's a 9. That's tough. That took a lot of creativity and a lot of thinking and a little bit of algebra. Then all of a sudden an easier one comes. 1 minus sine squared. Where in the world could I find that? It's sitting right here. 1 minus sine squared. What does it equal? Cosine squared. So that equals cosine squared, and I'll just use x, over cosine of x. Now you guys haven't dealt with these, like ever. But this is the same thing as x squared over x. Wouldn't that just be x? So, because, this is x times x up here over x, and one of them would cancel. So this is the same thing as cosine x times cosine x all over cosine x. So one of them is going to cancel, and I'm left with 1. And after you've done 10,000 of these, you just don't even look at it. You just go, oh, that's cosine x. Okay? See? Look at the difference. This one's pretty dang easy. This one's not so easy. That's the way this stuff is. Okay. Now, if you remember, if you move cosine 90 degrees, what are you going to get? You're going to get sine. So you're going to get sine of theta. And if you don't believe it, you can go back to your equation, and there it is. Cosine moved 90 degrees is sine. So we just substituted it. Plus 4 sine of theta. Well, 4 bananas plus 1 banana is 5 bananas. And you just simplified this crazy looking original thing. Hopefully you're getting better. So what if I move sine 90 degrees? Well, that would turn into cosine. What did I say not to mess with? This. So that means go for it. What is cotangent? Well, if you remember, cotangent, now you got to remove these little squareds from your brain. It equals cosine over sine. So that's cosine of theta over sine of theta times, remember this right here, 3 sine theta. We'll just go ahead and throw that over 1. Cross reduce, just like that. This is like 3x, and that's like an x. So the x's just cancel, and you're left with the 3. So I end up with 3 cosine theta plus 1 cosine theta gives me a total of 4 cosine theta in there. I have simplified it. I keep getting off the page, sorry. Okay, one thing I have not brought your attention to is you need to get on the hunt for sine squared plus cosine squared. As you work with this stuff, that's one of the things that will just jump out at you. It's the most famous identity. Sine squared plus cosine squared equals 1. And so as soon as you can pair these things up, man, does that simplify nice. So I'm going to pair these guys up, and I'm going to go, hey, that's just equal to 1. So I'm going to rewrite this as 1 plus cotangent squared theta. And this is a moment where you could pat yourself on the back and say, you know what, I've done a lot of good, so I think I'm done. No, this plus this does equal 1. We know that from the formula. But is there a way I can continue? So you go on the hunt. Where's 1 plus cotangent squared? It's right there. What does it equal? Cosecant squared. Cosecant squared theta. There it is. There it is. Okay. This guy. Well, I always attack these first because they're pretty darn easy to just identify. So cotangent, pi over 2 minus x. Cotangent, pi over 2 minus whatever, x, right there, equals tangent. So I know that this is minus tangent. I'll stick with x. Don't mess with this. Remember the golden rule. So what is secant? Oh, and don't worry about the 4. Do not worry about the 4. Just worry about the secant. What does secant equal? 1 over cosine. So I'm going to go here. I'm going to say, okay, 4 times 1 over cosine times sine, and there's where I'm at. Now wait a minute. What if I multiplied this all together? Well, I'm gonna keep this out of my mind for a second, and I'm gonna go 4 times sine of x over cosine of x. Now why did I do that? Well, I see that this is tangent, and I remember that sine over cosine, boy, I'm bad at this today. Sine over cosine in my memory bank is right over here. Sine over cosine equals tangent. So I'm going to make this 4 tangent x minus tangent x, and I get 3 tangent x. This comes with time and practice, you guys. So I've got 4 minutes, and I got 2 problems to solve. This is going to be a little different. This has nothing to do with this stuff. This says find all the solutions within this interval, which means my answers can be between 0 and 360 degrees. That's what this is saying, okay? Now, I'm going to divide by -2, divide by -2. This is more of a review problem than anything. Now, remember, the negative should always stay in the numerator because my hypotenuse can never be negative. And now I have my adjacent side and my hypotenuse, because that's what cosine is. And I need to think for a second. Where could this even happen? Remember, all solutions. So where could cosine be negative? Only where the adjacent side is negative. So, and I can tell this is going to be a 45, 45, 90 because of that square root of 2. So if I investigated here, this is positive, this is positive, this is positive. If I investigated here, this is positive, and this is positive, so cosine, adjacent over hypotenuse would be positive, so I just eliminated these 2 quadrants. So here we go. One of the possibilities would be if this was a 2, and this is a negative square root of 2. Now some students get a little bit weirded out. Remember, this would be a 45, because it's like, wait a minute, that's not a 45, 45, 90. Oh, it certainly is. Remember your rule, x square root of 2. If I multiplied this by the square root of 2, wouldn't I get the square root of 4, which is 2? So it's a sneaky one. It is a 45, 45, 90, however. And I would get adjacent over hypotenuse. Now, some of you are going to want to say, hey, so my answer is 45? No. My answer is how far I spun the spinner to get there. So it'd be 135. But wait a minute. That's not the only place that this could happen. It could also happen right here, where this side is the negative square root of 2. That's my adjacent side. There is a little 45 right in here, and this is 2. So how far did I spin my spinner to get there? 180 plus 45 is 225 degrees. So there's my 2 answers where this could happen. Last problem. This guy, you have to remember this. X squared equals 1. Remember, it's the way I teach it is bada boom, bada bing, do the right thing. Because it's both plus or minus the square root of 1. So I'm going to carry that on here. Bada boom, bada bing, do the right thing. Hope your algebra teacher taught you that. So you get sine of x. Just like over here, you'd get x is plus or minus 1. You get sine of x over here is plus or minus 1. Now we got to do some thinking. Isn't sine by definition opposite over hypotenuse? How can these 2 things be equal to 1? Well, that means the opposite has to equal the hypotenuse. Well, where does that happen? Well, it definitely doesn't happen here because my opposite side disappears. But it does happen at 90. You see how this opposite side and the hypotenuse are equal? So 90 degrees is one of my answers. If I go over to 180, I know that that doesn't happen because my opposite side disappears again. And look what happens at 270. My opposite side is negative. My hypotenuse is positive, but they are equal. And that's where I get another -1. So 270 degrees is my other answer, 90 and 270.